in the rectangle at the top of the page, for the functions y equals a times the sine of bx and y equals a times the cosine of bx, the amplitude for the function, right, is just the absolute value of a, and the period in the graph of the function is equal to 2 pi divided by b. So armed with that information, we can calculate the amplitude and period in the graph of a transformed sine or cosine function, right, from these formulas. So in exercise, you're instructed to determine the amplitude and period of each function without graphing. So in the first case, we have y is equal to minus 4 times the cosine of 2x. Well, a in this case is equal to minus 4, b is equal to 2. So the amplitude in the graph of this function, right, is equal to the absolute value of a, and the absolute value of a is equal to the absolute value of negative 4, which is equal to 4. So the amplitude is 4. Okay. The period t is equal to 2 pi divided by b, and b is positive. Okay. And so 2 pi divided by 2 is equal to pi radians. Okay. So the graph of this cosine function, right, repeats itself every pi radians. Any questions on that? Okay, the next example, we have y is equal to 6 times the sine of pi x. So a is equal to 6, and b is equal to pi. So in the graph of this sine function, transform sine function, the amplitude, which is equal to absolute value of a, will equal 6 units. And the period t, which is equal to 2 pi over pi, is equal to 2 radians. Okay. So every 2 radians, right, the graph will repeat itself. In the next example, we have y is equal to 2 times the cosine of minus 3x. Now first, you might be inclined to say, well, a is equal to 2 and b is equal to negative 3. But b can't be negative, can it? Right? And the rectangle says b has to be greater than 0. So how do we get rid of that minus sign? You're on you have sort of the right idea. Is cosine an even function or non-function? It's even, right? So cosine of minus pi is equal to the cosine of plus pi, right? It's an even function. So this minus sign, we can just drop it, right? So this is equivalent to y equals 2 times the cosine of plus 3x. Right? Cosine is an even function. A is equal to 2 now, and B is equal to 3. So the amplitude in this case now. So what we end up graphing is this equation, which has the same graph as this equation. Okay? They're identical. So the amplitude equal to absolute value of A is equal to 2 in this case. And the period T is equal to 2 pi over B, which is positive now. And B is equal to 3. So the period is 2 pi over 3 radians. The graph, either of these equations, right, repeats itself every 2 pi over 3 radians. Okay. All right, y equals 5 times the sine. Oops, I did that backwards. Y equals 5 times the sine of minus 8x. Okay. So initially, right, looks like A is equal to 5 and B is equal to negative 8. But B can't be negative. So how do we get rid of the minus sign? You sine an even or an odd function. Odd, right? The sine of minus pi radians is equal to the negative of the sine of pi radians, right? So remember that minus sign up front is the same as minus 1, right? That's minus 1 times the sine of pi. Okay. So we can pull the minus sign up front. The sine's an odd function. We have y is equal to minus 5 times the sine of plus 8x. Sine is an odd function. And now A is equal to negative 5, and B is equal to 8. So the amplitude in the graph is equal to absolute value of A is equal to absolute value negative 5, which is 5. And the period T, how often the graph repeats itself, is equal to 2 pi over B. And B is equal to 8. So 2 pi over 8, which is equal to pi over 4 radians. So every pi over 4 radians, right, the graph of that sine transform sine function repeats itself. Okay. Any questions on that? Okay. So if you flip over to page 5, we are going to sketch one cycle of the graph of the function f of x. And I've provided you with a grid down below. And so when it talks about key points, we're talking about where the graph crosses the x-axis. So we're talking about x-intercepts. And we're talking about the highest point on the graph, right, which we call local maximum, the top of a hill, and the lowest point on the graph, which we call local minimum, which is the bottom of the hill. Okay. All right. So we have f of x. Our function is f of x is equal to 3 times the sine of 2x. So a is equal to 3 B is equal to 2. Okay. All right, so step 1, okay, and these are my steps. Okay. If you got a better way of doing it, right? Certainly do your way. Okay. But step 1 for me is find the amplitude and period. Okay. Well, the amplitude is the absolute value of A, which is 3. And the period, how often the graph repeats itself, right? Or the length of one cycle is equal to 2 pi over B. And B is equal to 2. So one period or one cycle has length pi radians. Okay. Now, back on, you don't have to flip back to this, I'm putting it on the overhead, right? So the key points, right, for sine x, right, for this one cycle or one period is where the graph crosses the x-axis, right? So there are 3 x-intercepts. And then another key point is the highest point on the graph in that cycle, that period, which is this point right here, and the lowest point on the graph for that in that cycle, which is this point right here. So we need to calculate the x coordinates for these 5 key points in our transformed sine function on page 5. Okay. And this is one way of doing it. Okay. So in step 2, we have to find the x coordinates for the 5 key points. Okay. Well, as on page 1, our graph for one cycle is going to begin at x equals 0, and one period is pi radians. So one cycle or one period is going to start at x equals 0 and end at pi radians. Okay. So 0 comes automatically. Pi is because of the period. Okay. Now, the 3 other x coordinates, right, are all 5 of these x coordinates are equidistant apart. So the easiest way for me to find the other 3 x coordinates is first to find the middle one, right, which is the midpoint between 0 and pi. And the midpoint between 0 and pi, right, is 1/2 of pi. So that's the middle x coordinate. Okay. That is the midpoint between pi and 0. Okay, 1/2 of pi. I mean, technically, you take pi minus 0, right? That's the distance between pi and 0, and then multiply by 1/2, and you get pi over 2. Okay. Then to find the remaining 2 x coordinates, we take the midpoint between 0 and pi over 2 to get this x coordinate. Well, the midpoint between 0 and pi over 2 is just 1/2 of pi over 2, which is pi over 4. So now we got 1, 2, 3, 4 of the x coordinates. Okay. The hard part for some would be finding the midpoint between pi over 2 and pi. And the midpoint between pi over 2 and pi is 3 pi over 4. That's 1/2 of pi minus pi over 2. Okay. No, it's not. It's 1/2. Actually, that's supposed to be a plus, not a minus. I apologize. You're taking the average of the two numbers. Gives you the midpoint. Okay. And so the midpoint of pi over 2 and pi is 3 pi over 4. Okay. So those are the x coordinates in the graph of this function. So down below on the grid I provided you with, right, we can do two things now. We know the amplitude is 3 from step 1, so we can label the y-axis 1, 2, 3, 4, right? We know the maximum y values are going to be 3, and the minimum y value is going to be minus 3. And now we know the 5x coordinates in the graph of one cycle. So I did 2 hash marks, right, between each x coordinate. So the first one is 0. The second one is pi over 4. The third one is pi over 2. The fourth one is 3 pi over 4. And the fifth one is pi. Okay? And there's a reason why I did that, which will show up later. Okay? Why I went 2 hash marks instead of 1. But you can see all those x coordinates are equidistant. Okay? All right. So now that we know the x coordinates, we got to find the y coordinates for each x coordinate, right? You know how to do that. So step 3 is find the y coordinates, and then we just plot the points and play connect the dots. So we know our x values. There's 0, pi over 4, pi over 2, 3 pi over 4, and pi. And then the y values are 3 times the sine of 2x. Okay? So when we put in 0 for x, we have 2 times 0, which is 0. And so we have y is equal to 3 times the sine of 0. Sine of 0 is 0, so we just have 3 times 0, which is 0. Okay? So this first ordered pair is at the origin. Okay? The first key point is at the origin. Then when we put in pi over 4 in for x, we have 3 times the sine of 2 times pi over 4. Well, 2 times pi over 4 is pi over 2. And the sine of pi over 2 is 1. So this is equal to 3 times 1, which is equal to 3. And so the second ordered pair is pi over 4, 3. Okay? x is equal to pi over 2, y is equal to 3 times the sine of 2 times pi over 2, which is equal to 3 times the sine of pi, and the sine of pi is equal to 0. So this is 3 times 0, which is 0. And so our third order pair is pi over 2, 0. And then when we put in 3 pi over 4 in for x, it's 3 times the sine of 2 times 3 pi over 4. 2 times 3 pi over 4 is pi over 2. The sine of 3 pi over 2 is equal to negative 1. So the third ordered pair is 3 pi over 4, negative 3. And then lastly, we have pi and so when x is equal to pi, y is equal to 3 times the sine of 2 pi. Sine of 2 pi is 0. So our last ordered pair is pi 0. So far, so good. And now we plot the points. The first one is 0, 0. That's right here. That's the origin. The next one is pi over 4, 3. Right, so here's x equals pi over 4. And we go up 3. And then the next point is pi over 2, 0, which is an x-intercept right here. And then we have 3 pi over 4, negative 3. So here's 3 pi over 4. We go down 3. And then we have pi 0, which is another x-intercept. And now we connect the dots with the smooth sine curve. And that is roughly what the graph of y equals 3 times the sine of 2x looks like. Okay. This is one cycle, which is also called one period. Okie dokie. Looks like you've had enough. You got everything packed up and you're ready to head out the door. Yes, ma'am.
Could you move it down?
Down?
Wait, I mean, up.
Oh, sorry. Okay. So this will be on the exam on Thursday. Okay. So have a good day and I'll see you Wednesday.